Hey guys, welcome. Thank you very much for coming down today and enduring the walk. So my name's Daniel Soul. I'm a program manager in the Azure Compute group. Specifically, I actually work in a Linux team. And I'm going to be talking to you today about the Azure VM Image Builder service. It was originally called Image Template, and then we decided to change the name early in. This product is in very early stages of development. So what I'm actually going to talk to you today, I'm going to show you some demos and show you what our sort of vision is, and I'd like your feedback on that. Also, I'd like to point out that this is actually a Linux first service. So what I'm actually going to be talking to you today is about Linux image customization. Having the ability to support Windows customization is on our roadmap. The reason why we've gone down the Linux first path is because there's some more challenges to actually customizing Linux images over Windows, and that was more of a pain point for our customers. But like I say, customizing Windows images and making that supported on this system is on our roadmap. Okay, so I'm going to talk about image building today. I'm going to talk about the service, and then I'm going to talk about the management, security, and scale, and then integration with CI/CD. As I walk through this, you're going to see how you can essentially build out images, and you can already see how this will apply and integrate within your own CI/CD systems. Like I say, this is in very early stages of release. So why do people create custom images? What's the purpose? Why do they do it? We have vanilla OS images in the galleries, so why do we do it? There's a couple of reasons. First of all, it could be performance. Customers want the application and the operating system already configured when the VM boots. They don't want to have to do post-provisioning tasks. Second, it could be security and governance. There's a golden image that gets deployed, and this could have certain security settings or standard corporate settings that are required. Thirdly, it could be licensing requirements. So an example of that could be if you're a Red Hat customer, you'd have noticed that we have Red Hat images in the Azure Marketplace, but they're pay-as-you-go, so you pay for the license and the compute. If you've already got your own Red Hat subscription, with eligible unused licenses, then you need to actually go and create your own customized image so you can use your own license. So when I think about creating custom images, if I think about creating Linux custom images, if it's the Red Hat case, I might need to take an ISO, and then I need to start building that up. I need to essentially boot that ISO, and then I need to configure the operating system, things like the network, the storage, other security config in there. I need to install the Linux agent, so it provisions or cloud init. And then essentially, then you need all the tooling and the infrastructure, and you've got to sit there and figure out how to do that. And it's a bit like going to the supermarket where you're buying all these ingredients, you've got all these different types of tools. Which ones do I use, and then how do I set it up? And I've got to invest that time to make that happen. So, and then it gets even more challenging if I'm supporting multiple clouds. There could be nuances between the different clouds. There's different requirements of how to set up images that boot on different clouds. So with that being said, we're launching the Azure VM Image Builder service. This is a preview of the private preview announcement that is actually tomorrow. So you'll see some media go out tomorrow about this. And essentially, the Azure Image Builder service is a service where you provide a template that essentially expresses how you want your image to be customized. So what's the source image, what customizations do I want, and then where to put it. You do not have to stand up any infrastructure at all. This is an end-to-end service. All you have to do is provide an endpoint where you want the image to be spat out to. So what are we targeting for private preview? The ability for you to migrate your existing image customization pipelines to this service. So if you're customizing images using shell scripts, you can literally lift out those shell scripts, and then they can be ingested by the image builder, and I'll show you some examples of that. Migrating your Red Hat subscriptions to Azure. The Image Builder service has the option to ingest a Red Hat ISO. So you can literally point at a Red Hat ISO, it will take that ISO, and then at the end it will give you a bootable VHD. You will have to do nothing in between to make that boot on Azure. And then lastly, image management and distribution. An image, I always sort of make a funny joke, but it's not that funny. An image is a bit like buying a dog. A dog's not just for Christmas, it's for life. You have to maintain that, and it's like an image. It needs management, life cycle, versioning, distribution. It needs updating every now and then. So what we've done is we work with the shared image gallery team. And for those of you who haven't seen the shared image gallery, essentially this is a service that allows you to manage your images through lifecycle. And I'll talk a bit more about that in a second. So the Azure Image Builder service, what does it actually look like at a high level? Essentially, it's made up of 3 components. You have your source, your customize, and your distribute. So for the source, I've already mentioned you can ingest a Red Hat ISO. What you do is you go to your Red Hat Cloud Access portal, and then you just essentially go down, find the Red Hat image you want. So we support 7.3 to 7.5 inclusive. You copy the link for the ISO, and then you paste that into the template. Secondly, we also support ingesting Azure-based Linux images. For private preview, we're only supporting Ubuntu 18.04 and 16.04. As time goes on, we will open up the ability to ingest more. We just need to test more images and make sure there's no hidden issues there. One thing that's on our roadmap is the ability to actually ingest an existing customized image that you may already have. So you can actually have the whole image lifecycle. If you imagine you've already built your image, the image builder's gone and built your customized image, it may be that there's a CVE and there's a patch, and you just want to apply that to that image. What we want to do is actually support the ability to take that customized image, apply another customization, and then redistribute it again for you. Secondly, customize. Currently, we only support one type of customizer. That is a shell script customizer. So literally, you can make your shell scripts available to the image building service. It will ingest them and then run them. You can actually provide multiples of these, and the image builder service will iterate them through sequentially. What you'll notice under there is the Packer logo. This service is actually built on Azure Kubernetes and Packer. So if anybody's built images before, they'll know that Packer is an awesome tool to actually build images and customize images. And when you actually see the template, you'll see some slight likenesses to the Packer provisioner configs. Oh, right, it's gone. So we're actually built on Packer, and we have a very good relationship with the Packer team. And then lastly, distribute. We support distributing to a managed image. So for those of you who are already building custom images, you'll most likely be familiar with the managed image. And additionally, we support distributing to the shared image gallery. How many people here have heard of the shared image gallery? Okay, a few of you. The shared image gallery is really, really cool. Because I test this system a lot, I spend a lot of time working with the shared image gallery. This has just gone public preview. In my last deck, there's actually a link to another shared image gallery session. Essentially, think of the shared image gallery as a container for multiple image definitions. And one of those could be, say, my Red Hat 7.5 images, my Red Hat 7.3 images, or whatever. And once you have that image definition, you then have versions underneath that. And what you can do is you can actually RBAC those versions, and then you can go and share them with your friend in a different subscription, as long as he's in the same tenant. There's also some other advantages. Shared image gallery also can distribute your image to multiple regions. So I can just say, here's shared image gallery, go and distribute to West US, East US, and it will just take care of that. If you were going down the managed image routes, you would have to have another managed image distribution endpoint to say, go and replicate to this region or distribute the image to this region. So the shared image gallery is definitely really, really cool, cool stuff, and I suggest you go and have a look at it. So next one, the management, scale, and security. The Azure Image Builder is a first-party resource in Azure, and you'll see this in a template in a minute. And essentially, the way it works is you provide a customization template, and in there you will see the source, the customizations, and then the destinations, essentially where you want to dump the image out to. Inside there, you can specify all the details. Once the service has actually ingested the image template, this is an artifact that stays in the service, and you will see it in your subscription. If you click in the portal and you select Show Hidden Artifacts, you will see an image template artifact in there, or if you use the CLI, that will throw it out for you anyhow. And once you've got the templates been ingested into the system, then you need to invoke a build on it. So you actually say, right, here's the template, now go and run the build. And that's the point where the image builder service actually then goes and stands up all the artifacts to essentially go and create and customize your image and distribute it out. Lastly, for scaling, RBAC, and versioning, we're building on top of the shared image gallery that supports all of this. So like I mentioned before, shared image gallery supports the ability to version images. It also supports scaling. Some of you may have been in a position where if you're launching, say, scale sets with thousands of VMs, if you're essentially building them from one custom image, you may see some reduced provisioning performance because of the throttling that could occur on that single custom image. Managed, the shared image gallery allows you to have multiple copies of an image to support scaling at large scale. And then lastly there, auditing. Any image that gets created by the image builder is fully auditable, and you can see that in the portal and how it's being created. So enough of me talking. Let's have a look at some code. So what I've got here, I've got a public repo, and what I'm just going to show you is I'm going to show you some image templates that you submit to the service. So first of all, I shall start with one that uses a platform image. So what you can see is here you can see the resource type, virtual machine images. Then you have your source. Notice this one here is a platform image, and this doesn't look that dissimilar. You're essentially specifying publish off the SKU version like you do when you normally create a VM. No differences there. And then next one, you have customize. So here you pass in shell scripts. Notice that this is an array. You can actually pass in multiple customizations in here. And like I mentioned, the image builder will run through those sequentially. If at any point that one of those scripts fails, the image pipeline will stop, and then it will show you an error to go and resolve it. Distribute. So here, this is an array as well. I can distribute to multiple targets. So this type here is a managed image, and then I pass in essentially a managed image ID, which is essentially the resource ID of the resource group /images/image name, and then you have the run output. The run output is actually the image name, and I'm going to show you a bit more examples of that in a second. And then here you have your tags that you can specify. So that's using a source of an existing platform image. If I want to ingest a Red Hat ISO, I can do. One of the key differences is that the type changes to ISO, and then you have your source URI. So if you want to essentially ingest that source URI, you go to your Red Hat customer portal, and then you scroll down here, you look for your binary DVD, and then literally copy the link address straight out of that, and then paste it into your template. It's pretty much as simple as that. And then also you have the checksum. This one here is slightly different. You can see in the distribute, I'm actually distributing to two different targets. One of these is obviously managed image, which we saw before. And then here I also have the shared image gallery target. And what you'll notice here, I can specify the replication regions. So in the pipeline, I can just say to the shared image gallery, right, I want it here against these regions. I believe for public preview now, they're supporting all public Azure data centers. So, right. So how do we actually create this? What I tend to do is when I'm testing, I like to use ARM templates. The reason I like to use ARM templates is just because I can parameterize them and they're pretty quick. So what I've got is here, I've got a parameters file which has got things like the publisher, the offer, things that we mentioned. Here you can see I've got my my customization script path. I've got a link to a gallery ID, so this is talking to a shared image gallery. I've got my managed image resource group ID, and then I'm dumping out the image name, so that's a custom image name, and the shared image gallery definition, and then a region. So if I want to actually go and deploy that, all I need to go and do is, let's copy this, set up the params, and then now what I'm actually doing, I'm actually going to submit this deployment to ARM. ARM's now going to send it to the Azure Image Builder resource provider, and what it's actually doing is it's submitting the template into the system. This one will go pretty quick. You can see it's running already. What I can do is I can check the status of what's actually happening. So if I do that, I can get it to dump the status, and what you can actually see is here, it said provisioning state succeeded. Yeah, the little donut's still circling just because it's going between the Azure Image Builder service is saying complete, ARM's picking up that signal, and then the client's picking up that signal, so there's always just a tad bit more latency. What you'll also notice is it will say last run status. It's never been run. So what happens is you submit an image to the Image Builder service, and then you go and invoke run on that particular image. So this image is now, image template is actually ready to go and to be run. And what I can actually do is I can see the image template artifact as well. I can dump that out, and what you can see is here, Ubuntu Ignite TMPL 6, and you can see it's got a type of image template. Now, if I actually want to hit the run on that, all I do is here, I pass in the template name, and I invoke a run action on that. Let's go and do this. And now what this will do is this will start running. This will probably take about 30 minutes, 35 minutes to run through the system and start distributing it out. If I want to check on the status of what's happening there, all I do is I can run this show command. It's not there. Let's go and grab that. So I can get the status. And what you can see is here in last run status, you can actually see the run state now is changed to running, and it's in the building phase. So that actually means it's in the first phase. When it actually goes into customize, you'll see it will say customizing there. So there's some pretty good stuff. What will happen is this will run, and then at the end it will just come back and say complete. You can actually see that there's other runs that I've actually done on here, and I can show you what they look like. So here you can see other images that I've built. I'm not very creative, so Ubuntu Ignite 02, I did that last night, and 01 a bit earlier. This is dumping out the images from the shared image gallery. If you remember, the template I was using was dumping out to the shared image gallery and managed disk. Obviously, this is the managed image, and this is the shared image gallery, and this is the version that it's dumped out. So we're obviously tight on time. Let's go back to the slides. So lastly, what I wanted to actually show you is how do you integrate this into an existing CI/CD pipeline? What you can do is, I'm using VSTS DevOps here, but you could use Jenkins with Travis. It really doesn't make any difference. Essentially, what I'm doing is here, I've got a GitHub repo that's got my application in there. It's also got all the infrastructure as code. So I've got things like Terraform in there, I've got Ansible, and then I've got the image builder config all sitting in that repository. What I do is I then use, I have a VSTS build pipeline to build my application, and then I have a release pipeline as well. I'm using an Azure container instance at the top, and what it does is, in the release pipeline, the first thing it does, it makes a call to Azure Image Builder. It takes the configuration and says to Azure Image Builder, here's the template and the configuration of the image I want you to go and create. it first of all submits the template. As soon as it gets an ACK back, it will then invoke creating the image, a bit like I did. And it will run for however long that takes. Once that image is created, then what happens is that particular step finishes in VSTS, and then I use Terraform to pick that image up and then go and build a bunch of infrastructure. In this case, the infrastructure is a scale set, a load balancer, public IP address, and a website underneath it. And what it actually looks like, it looks something like this. You can see the code on, or small bit of the code on the left, and then you can see some of the steps in the release pipeline. So this is literally just a very skimmed session of what some of the possibilities are with this. So in summary, what you've seen is how we can use Image Builder to ingest different ISOs, how we can also then run different customizations and then have distribution endpoints. And at no point did I stand up any infrastructure. All I did was submit a template. As also I mentioned, we're built on top of shared image gallery, so you can do RBAC on those particular images that get created by the shared image gallery. You can version them. It's fully audited as well. So if you're interested in a bit more of detail on this, we've actually got, I call it the daddy session tomorrow. This will be about an hour, and we'll spend a lot more time talking about this in detail. This is very much an intro into what's possible. The private preview, that will be announced actually tomorrow, so this is pretty early on. If people have got any questions, feel free to ping me or grab me after this session, or better still, come to tomorrow's session. We'll also have the principal dev lead there as well, and I'll also have the program manager for the shared image gallery, so we can berate him if you don't like that as well. Lastly, there's a session as well on scale sets and the shared image gallery. Definitely recommend you should go to that one. So thank you very much for your time. I'll take questions after. Thank you.